Okay, I guess we probably better to get started here. Good morning, everybody. I want to just kind of back up just slightly from last week. I had covered some things, and then I decided that I wanted to add just a little bit to it. So I think this is important, so I want to kind of go back to this. So what we're talking about is things that were found on asteroids. And basically, there's an asteroid named Bennu, which we've been talking about. And on Bennu was discovered a variety of different amino acids that were taken from a sample that was taken from Bennu. And they sent a probe out to get a sample of this from this asteroid. And what they found on here is they found 14 of the 20 amino acids that are found in living things. And amino acids are the basic building blocks of protein. So on this chart here, you see, and highlighted in green here, the ones that were found on this asteroid. And a single protein is made up of hundreds or even thousands of amino acids arranged in a specific order in long chains. And some proteins actually contain chains up to as long as 27,000 to 35,000 different amino acids in a single chain. So it's amazing. If you take these 20 amino acids, you link them together in a specific order, somewhere, again, it could be as many as 35,000 of these different amino acids. This is what's used to make up a single protein. So this is pretty astounding here, that what's found in these asteroids is just the amino acids. It's not proteins. It's the building blocks of proteins. So we're not even close to something that's living here at this point. So this is what's important to remember here. So we talked last week about something called panspermia. So now the evolutionists see these amino acids and nucleotides. Nucleotides are the basic building blocks of DNA. They've been found on asteroids. So now they're finding it so difficult to believe that life could have evolved here. They're seeing the scientific issues with that. So now they're saying, okay, well, maybe something out in outer space seeded life here. And that's something called panspermia. We discussed that a little bit last week, but this, again, is the thought that somehow these elements made it here to Earth on asteroids that collided with the Earth, and somehow, through random chance, formed these incredibly intense amino acids, numbers of amino acids that somehow link together in these incredibly long chains to somehow form protein. But even if you could do that, you're not even close to life at that point. So this, again, pushes the issue out into outer space. So now, with this finding of nucleotides and amino acids, this is a headline from a website named Geekspin, where they're now stating something like this. They're stating human DNA was detected in a 2 billion-year-old meteorite. The subtitle of this is New NASA Data Revives the Theory That Life on Earth Came from Space. And I gotta say, this statement is so inaccurate that maybe the only accurate word in here is detected. That's probably the only word out of this that actually is probably there. And again, amino acids and nucleotides were found in these two asteroids, Bennu and Ryugu, and not human DNA. Again, amino acids are not even close to forming an amino acid, a strand of DNA. And of course, 2 billion-year-old dates like this, where did they get that from? Again, this is an assumption based on, no creator. This is an assumption based on evolutionary assumptions. So it's totally misrepresenting. This would be like saying, if you found a couple letters, you could assume that you could put together the entire works of Shakespeare out of a couple of letters in the alphabet. I mean, that's how far away. It's actually further away than that, because amino acids are far more complex than even what Shakespeare wrote. So again, this is totally misrepresenting what we see here. And they can't provide us a technically or a scientifically based mechanism of how life began on our planet. So our planet just happens to have the right ideal location, conditions for supporting and sustaining life. So they can say that they can't provide us a scientifically sound method to produce life on Earth, but they can say, hey, this must have happened out in outer space, in the absolute vacuum of outer space and harsh temperatures and cosmic rays that would have broken this kind of stuff down. So it's just problem after problem after problem. But in spite of that, you might have heard of something called the Miller-Urey experiment. This was an experiment conducted in 1953, and this experiment claims that that life had been created. So in 1953, a guy named Stanley Miller set up an experiment to produce amino acids from chemicals. So the goal was to show experimentally how life could have began. So living matter, again, composed of proteins, long chains of amino acids. Even if you can produce an amino acid, again, you're not even close to producing life. But if you could show, or if he could show, basically, that you could form amino acids from chemicals under the right conditions, they're going to jump to the conclusion, basically, that, hey, this is alive. You know, they're making a bunch of jumps over big leaps, over big chasms that aren't justified. But this is, again, this is kind of what they're claiming here. So they put together this experiment involved simulating some of the hypothetical conditions of early Earth, the early Earth atmosphere, in a laboratory. And they took an electrical spark through a mixture of gases. And the apparatus he used was similar to what you see here. So water was boiled to produce a mixture of gases, including ammonia and methane and hydrogen and water vapor. And the upper flask here held an atmosphere presumed to simulate the primitive Earth's atmosphere. So it was what was called a reducing atmosphere. In other words, it means that it was free, or it was void of any free oxygen molecules. There was no oxygen in this. And this is important because in an oxidizing environment, which is what we have now currently, has the presence of oxygen in it, the synthesis of amino acids actually couldn't occur. They would have actually been destroyed by the process of oxidization, which is the process of absorbing oxygen. So you've got a paradox here. They assume there's no oxygen. We have oxygen in our atmosphere. How did this happen? How could this happen unless there wasn't any oxygen? So, so the gases in the upper bottle were subjected to a small continuous electrical spark, which is, they say, simulating lightning. And the lower bottle represents the early ocean. It was kept boiling in order to keep the mixture in the upper bottle stirred up and circulating. So, so the claim here that they did actually produce some amino acids from this. But the claim at the time was that this was a big success. And from dirty water and lightning, they've produced life. So the newspapers all over the world said, hey, life has been created. It was hailed then, and it kind of is still today, as a great victory for science over God. But if you take a look at Miller's primitive environment here, he had a vacuum pump to continually circulate the vapors. He had special tubing to seal off the outside world. He had special distilled water inlets and outlets, an electrical element producing 212-degree water temperature, the point at which water boils, electrical contacts to make a continuous, very low amperage spark, and a trap environment to immediately siphon off any nitrogenous products before they were destroyed. And so I wonder if the ancient world was this well funded or controlled. I mean, you think of this, I mean, it took a lot of intelligence just to do this. So the thought of that this could happen, you know, basically out of randomness outside of a laboratory seems pretty far-fetched here. So what was also important was the amino acids themselves that were produced in this experiment. And in actuality, there's over 2,000 types of amino acids that are known, but only 20 of them are actually found in living things. So most amino acids are not found in life. And the amino acids that were generated in this experiment were generated in both what is called the L and D forms, which are left and right atomic arrangements of the molecules, and thus they're termed left-handed and right-handed forms. So living organisms only use the L form, never the D form, and the presence of significant D form molecules make it unlikely, if not impossible, that this generation of compounds could be used to form any living thing. So amino acids are only the building blocks of proteins, and even if this experiment produced amino acids, in the L form only, which it didn't, this again still a far cry from actually producing any life. And also since 1930 it's been known that amino acids cannot link together if oxygen is present. So this means that proteins could not have evolved from chance chemical reactions if the atmosphere actually contained oxygen. So because of this, they're forced to claim that early Earth's atmosphere didn't have any oxygen, right? I mean, that's, what else can they say at that point? Because of this, according to an article from Scientific American from August of 2009, they state that the breathable air we enjoy today originated from tiny organisms. I'm not sure how they know that, although the details remain lost in geologic time. So we assume but the details, they're lost. We don't know what these details really are, right? So they claim that the early primitive microbes lived and thrived in the absence of oxygen. But then, roughly 2.45 billion years ago, oxygen somehow became a significant component of the Earth's atmosphere. Although the details of this, yeah, they're a little fuzzy. We're just not quite sure. They don't know the adequate mechanism about how oxygen all of a sudden forms. So this is what evolutionary scientists refer to as the Great Oxidation Event. So again, this is something imagined. Mysteries, of course, remain about this. They state that tiny organisms known as cyanobacteria or blue-green algae would have produced photosynthesis using sunshine, water, and carbon dioxide to produce carbohydrates and, yes, oxygen. So what occurred 2.45 billion years ago is that it enabled these bacteria to take over. Where did these bacteria come from? Where did they even form in the first place? Bacteria, we'll see, not so easy. I mean, this is complex too. I mean, people think of bacteria as simple. It's not. It's really complex. Could this have happened by arranging themselves out of random processes alone? What were the oxygen levels at the time? Why did it take another billion years? And this billion years was dubbed the boring billion by scientists, for these oxygen levels to rise high enough to enable the evolution of animals and, of course, us. So just how could the amount of atmospheric oxygen we have today reach its present level? So no evolutionary theory has been able to explain why Earth's atmosphere has the amount of oxygen that it has today. So today we know that the Earth's atmosphere is composed of roughly 21% oxygen gas. It's actually 20.95%. So for humans, the minimum amount of oxygen necessary to sustain life is said to be around 19.5%. So just about 1.5% less than what we actually have. And while humans can survive at lower oxygen levels of around 16% cause impaired judgment, and levels of around 10% will cause fainting and death. So at the other end of the scale, going the other direction, if we go above 20.95%, a level of 23.5 is considered to be called what is enriched. And while not immediately lethal, continued exposure to this level poses long-term health risks. And thus, this is the highest level considered to be safe. So we have this range now of 19.5 to 23.5. Okay, any lower than 19.5 causes problems, any higher than 23.5 causes problems. So how do we get so lucky? How do we get so lucky to get 20.95%? Is this just an incredibly lucky chance? Do we hit the lottery here, the oxygen lottery? We rolled the dice and just happened to get what we needed, right? And how did it all happen at one time? Earlier in the class we discussed something called the anthropic principle, or sometimes as whimsically called the Goldilocks principle, in that there are so many aspects of what we find in the universe that are just right in order to be able to support life. So there are literally dozens of features in our universe that are just right or finely tuned in order to be able to sustain life. And that this appears to have been designed this way for the sake of human life. And also the thought that any of these factors, like oxygen here, would have been altered just slightly, all of a sudden life's not possible. I mean, so if we get, again, lower than 19.5% or higher than 23.5%, life can't really survive at that. So if we take a look at all these factors, it was calculated that the probability of all these factors occurring by random chance to be just right, so if you took all these different factors, was calculated to be less than 1 in 10 times the 311th power. So basically that's a 1 followed by 312 zeros. Okay, that's an insanely large number. And mathematicians have also said that anything above 10 to the 50th power, or a 1 with 50 zeros after it, is a statistical impossibility. So we are so far beyond that it's just not possible. This could not have been generated by randomness. And all these factors, realize, have to be present just to sustain existing life, not to allow life to randomly form from chance. So again, this is, again, not close. So anyway, this geoscientist named James Casting of Pennsylvania State University had this to say: it's not that easy why it should be balanced at 21% rather than 10 or 40%. We don't understand the modern oxygen control system that well. Well, apparently you don't, right? Also, in the chemistry of Earth's rocks, both on land and below ancient seas, it shows that the Earth has oxygen before the earliest fossils formed. So we tend to think of an oxygen-rich atmosphere as being essential to life because we would die without it. But in a bit of a paradox here, life's building blocks could not have formed in such an atmosphere. So it's like, it's a paradox here. You can't get one without the other. If you have one, you can't get the other. It's pretty amazing. So is there any evidence that the Earth's early atmosphere lacked oxygen? If it did, how did the oxygen come into being? And at what time? Did it just arrive at the right time, just by chance? So is there any evidence to support any of this? So now, with all these problems, here's another twist on the subject. Now this comes from Science Focus from the BBC. This was published on September 14th of 2025. And this is by no means is the only people that are talking about something like this. So apparently they're not bothered by facts, but they say now that scientists are now seriously asking if humans were seeded by aliens. And here's why. The idea that life on Earth began elsewhere in space has long been controversial, but it's now gaining attraction. It's been gaining attraction more recently due to the discoveries on these asteroids and meteors of organic material. But the thought that somehow that aliens are responsible for this is actually really not a particularly new idea. So on the website for Science Focus, which is listed at the bottom here, if you want I can get this to you, they state, where did life on Earth begin? That sounds like a relatively straightforward question. Is it? Actually, it's not if you read Genesis 1, but not so much if you reject creation. I mean, it's a big mystery to them. And they go on to say, surely on Earth began, well, on Earth, right? They think that it may have started on Earth, but maybe not. We know this planet has the right conditions for life to arise, they go on to say. And we see evidence stretching back more than 4 billion years, almost to its formation. And again, this 4 billion year idea, again, is a deduction because of the rejection of a creator. And they think, well, life obviously exists, right? We see life on Earth. We reject the idea of an intelligent designer. So what are we left with? We have to come up with, it must have done it by itself somehow. Okay, maybe it didn't do it on Earth here. Maybe aliens did this, okay? It just, when you look at it this way, it just sounds kind of crazy. So this is something now called directed panspermia. So instead of just panspermia, now it's directed panspermia. So to overcome these obstacles, Francis Crick, who was one of the scientists who played a critical role in the discovery of DNA, stepped in an attempt to save the day and answer this question. Now, Crick was known to be an atheist, not very willing to even consider Christian beliefs. And he saw DNA. He was part of the discovery of DNA. So wouldn't he have seen the extreme complexity in the DNA sequence? Maybe he just didn't notice that, or maybe this was he didn't notice this was evidence for design. Again, I just really don't understand this. You would think that the people that would be most apt to believe in an intelligent designer would be those that are in biology, because it is so exceedingly and insanely complex, it could never have happened by randomness. So he had this to say. Crick was a known humanist and an atheist who said, I do not respect Christian beliefs. I think they're ridiculous. And he thought that the world would be a better place without it. So in an attempt to answer this question, he co-authored a book called Life Itself, which proposed the idea that some sort of primordial life was purposely shipped to Earth by ETs, extraterrestrial, in spaceships. He called this idea directed panspermia. I just don't even know how to go much further than that. I mean, did he believe that aliens viewed us as like an experiment or something, or we're lab rats, or what? Some kind of grand, bizarre experiment? I just don't understand this. So we've seen what the evolutionists say about the origin of life. We kind of covered this a little bit last week, so I'm going to skip over this pretty quick. But some of the major creationist organizations, they say they're either part of God's original creation or the result of contamination, basically bringing these samples back. They were either contaminated by the spacecraft that went up there, or they were contaminated when they returned to Earth. But given the extreme caution that has been taken for this, I mean, you wouldn't send a spacecraft out to an asteroid to get a sample out of it and come back without taking the utmost caution not to contaminate the sample. I mean, that just seems a little crazy to me. So, so in recent video from Answers in Genesis, which is a leading creationist organization, they had a video titled, "They Found Human DNA on a Distant Space Rock?" ? So they're questioning that. So, because this is again what the evolutionists are claiming. They found DNA on a distant space rock, an asteroid. So Dr. Georgia Purdom states that although the components of proteins, DNA and RNA, have been found in space, the evidence from actual life in space is non-existent. So she's from Answers in Genesis, and they're correct in this statement that the components of proteins, which are the amino acids, and DNA and RNA, which the components are nucleotides, they correctly say that this isn't even close to finding DNA in a space rock. I mean, this isn't even close to that. And any organic material entrained in the ejecting fountains would have been pulverized, leaving on comets and asteroids a trail of evidence of their origins. So a guy named Kevin Lee, he's the pastor of a church in Port Orchard, Washington State, is a leading advocate of the hydroplate theory. And he describes the hydroplate view here. He says, with the understanding, hydroplate theory advocates can not only explain these recent discoveries, but Walt Brown, the developer of the hydroplate theory, and others have successfully predicted many of the recent findings that have been so perplexing to both secular scientists and even most creationist astronomers. And about 140 into the video, they talk about this. They say, the evidence of actual life in space is non-existent, except it is. It just didn't come from where they think it did, where the evolutionists think that it did. So numerous studies have reported the presence of microorganisms, including bacteria, within what are called chondritic, probably not pronouncing that right, meteorites, and were found in samples taken from the asteroid Ryugu. So the image you see here on the screen is an illustration depicting the components of a bacteria. Cell anatomy, which includes the capsule, the cell wall, the flagellum, which is how it propels itself around, that little tail on the back of it there, and many other complex features, including DNA. Again, this is not simple life. This is very, very complex. So we know some bacteria is beneficial. Beneficial bacteria, for example, assist us with our digestion of food as part of our microbiome, and also in the production of vitamins. But there's also some bacteria that's not good. But the point here is this is far from being primitive. This is far from being. This is very highly complex in their structures. So Where were these microorganisms found? Well, we just talked about chondrules, or mentioned it here. They have been found inside of what are named chondric meteorites, which are meteors containing what are called chondrules. And chondrules are strange, nearly spherical BB-sized objects that have been found in about 85% of all meteorites. And you can see them in this photo here, these circles. These are chondrules. And how did these form, though? And why do they contain bacteria? The standard evolutionary explanation for the formation of chondrules has recognized scientific problems. However, the hydroplate theory provides an answer to this question that explains how they would have formed, and thus the explanation for them being formed in these samples in asteroids. However, an explanation of this today, right now, would sidetrack our current discussion. So if you want to investigate this further, you can see page 418 in the 9th edition of In the Beginning, and it explains this. Again, I won't take the time to do it now, but it provides a logical answer that follows known scientific principles to explain where these came from. So bacteria is thought to be so light that it would have been able to withstand, at least some of it would have been able to withstand the forces of the eruption when the flood began, and then these chondrules would have formed around the bacteria to preserve them. Some organic material was pulverized and broke down into the amino acids and nucleotides that are found in Bennu and Ryugu. But the feeling here is that some of the bacteria could have survived this. What's significant is that bacteria do go dormant, but even though it goes dormant, it's still alive and can be revived. So when the samples on Ryugu were studied, within about 5.2 days, there was definitive growth in the samples indicating that they're actually living. So they cracked this thing open, they had this bacteria there, within about 5 days, they started to grow. So they went dormant, but they're still living, and they can be revived. Another interesting example of this occurring is found from insects that were encased and fossilized in amber. These are known to be among the best preserved fossils since they're rapidly encased in amber, which protects them from air and water, which rapidly would speed up the decay processes. So in a clean room laboratory, 30 to 40 dormant but living bacteria species were removed from the intestines of insects encased in amber found in the Dominican Republic. And when cultured, the bacteria grew. So this amber here is claimed by evolutionists to be 25 to 40 million years old. However, metabolism rates in even dormant bacteria are not zero, meaning that even if encased in amber, to preserve them would be extremely hard to fathom that they could be kept alive for 25 to 40 million years. So I suspect that these fossils obviously were formed at the beginning of the flood, only a few thousand years ago. It seems much more likely they could be kept alive for thousands of years instead of millions, doesn't it? Now realize that the claim that the materials that make up Ryugu were composed of unspoiled material left over from the formation of the solar system, they claim, 4.6 billion years ago. So how much harder is it to believe now that they last 4.6 billion years and not 25 to 40 million years? You know, 4.6 billion is way longer than even 25 to 40 million years. So again, it just doesn't fit. I mean, it just actually doesn't fit at all. So here's a picture of Ryugu. I think I showed this last week too, but you can see that it's a rock pile. As it turns around here, you see a lot of boulders on the surface. And it's actually been found to be made up of many smaller rocks and dust held together loosely by ice under the right conditions, because they would have all been injected from the earth in the same direction, would have coalesced to come together through a process called accretion, forming these asteroids. Now, evolutionary Big Bang model can't explain how asteroids like this form. They previously thought that they were solid rocks. We'll go over that in just a minute. But they're actually a loose rock pile, so made up of many smaller rounded boulders. So let's look at some other strange features of asteroids. So many asteroids also surprisingly have moons, like this asteroid named Ida and its moon named Dactyl. So this is the moon dactyl that's now orbiting around Ida. So in 1993, the Galileo spacecraft headed toward Jupiter took this picture about 2,000 miles from this asteroid. And to the surprise of most, it had a moon. We didn't know that. About 1 mile in diameter, orbiting about 60 miles away. And both Ida and Dactyl are composed of Earth-like rock. And we now know that at least 243 other asteroids have moons, and 10 of them actually have 2 moons. So according to the laws of orbital mechanics, capturing a moon in space would be unbelievably difficult unless both the asteroid and the nearby potential moon had very similar directions and speeds, and unless gases were surrounding them, somewhat of an atmosphere, would have provided some aerial braking to slow them down so the potential moon can be slowed down enough to be actually captured in orbit around the larger one. So this is something, of course, that's proposed by hydroplate theory, and it's logical. And remember back to, if you were here before, remember how we discussed the Apollo 13 spacecraft that was going toward the moon? They ejected some waste out from the Apollo 13 spacecraft. And what ended up happening was, much to their surprise, the materials that they ejected out actually started to orbit the spacecraft. They were dumbfounded by this. I mean, they were just completely surprised by this. So, again, this material they ejected out, going the same direction, the same travel path as the spacecraft was. It actually got caught by the gravitational influence of the spacecraft itself and started actually orbiting the spacecraft. Pretty amazing. So again, these are laws of physics. These are physical things that we, physics that we can, confirm. So from a distance, an asteroid looks like a leg rock. And as you'll see, this is what was expected until it was discovered that they weren't. However, many show by their low density that they contain something light, such as water or ice, or empty space. So at the best close-up pictures of how an asteroid shows millions of smaller rocks on its surface, just like we showed of that Ryugu. So asteroids are literally flying rock piles held together by gravity. So this is an important prediction of the hydroplate theory. This is prediction number 40, is that Waltz Brown had predicted that asteroids would be found to be rock piles, often with internal ice acting as a weak glue holding them together. This was clearly written in the 2001 8th edition of In the Beginning, and then it was confirmed in 2014, 13 years later. So again, the test of a powerful prediction theory is that, hey, do the predictions you make come true? I mean, can you have predictions that actually are found to be correct? Another one is prediction 41, which is the prediction that most of the rocks, pebble size or larger, composing of asteroids and comets, would be found to be rounded to some degree. So this prediction was made and it was confirmed in 2014. So can you guess why many are well-rounded? Ever been around a rock tumbler? Anybody ever have a rock tumbler when you were a little kid? So you throw rocks into a rock tumbler and it tumbles them around for a couple weeks, let's say. Maybe water and grit inside there, and you tumble them around. All of a sudden, and you take them out a couple weeks later, and they're now nice and polished, right? They've rounded off. They've knocked off all the sharp edges. So at the beginning of the flood, this huge rupture that wrapped around the Earth formed cliffs, each about 60 miles high, and rock at the base of the cliffs was ejected. It crumbled and was ejected up into outer space. And as it did, it would have tumbled around and knocked off some of the sides and would have given a rounded effect to these rocks. So, well, again, we'll see this on pictures we'll see in these asteroids. So this is, again, how rocks got these, on the surface of these asteroids, got this rounded look. Also surprising is that many asteroids have been found to be shaped like peanuts or rubber duckies. So how is that possible? This is because some asteroids have moons that had moons, have gently connected with their moon, like Itokawa, as shown here in this slide. And thus it has been described as looking like a peanut or a rubber ducky, with the smaller portion appearing to be the ducky's head, and the larger portion being the duck's body, or like a peanut, So Itokawa is around 2,000 feet long, so it's roughly about a quarter of a mile. And as stated, it's difficult to land even a small, precisely controlled spacecraft on an asteroid due to low gravity environment. So when the large size of these fragile bodies is considered, it's hard to imagine how this occurred randomly in space with no atmosphere to provide aerial braking, allowing them gently to emerge. If they were to collide with much force, they would shatter and disperse in many different directions because they're held together by low gravity and ice. So that's not something that would hold them together. So asteroids with thick atmospheres sometimes captured smaller asteroids and as moons, as we just discussed. It's, again, according to what we'd expect with hydroplate theory. And notice again the surface is what we predict. We see loose rocks held together, and we see boulders on the surface that are rounded. To give you a scope of the size of this, some of these boulders in this picture are over 150 feet in diameter. So just to give you kind of a sense of the size here. So the high velocity flow of bursting forth of the fountains of Great Deep produced many of these rounded objects, and hydroplate theory readily explains that. So what do the experts say about this? What does NASA say about this? What do the secular scientists say about this? A researcher named David Yeoman from NASA, from the Jet Propulsion Laboratory, seems stumped by what is observed due to their evolutionary viewpoint. In an article from 2006 titled Historic Japanese Asteroid Dated Amaze Researchers. It seems like they're always amazed, or they're dazed, or they're shocked, or they're puzzled. I mean, this just goes on and on. You see these words constantly in these kind of statements. Here he says, it's a major mystery how two objects the size of skyscrapers could collide without blowing each other to smithereens. It's a major mystery how this could happen. This is especially puzzling in a region of the solar system where gravitational forces would normally involve a collision at speeds of up to 2 kilometers per second. That's around 1.25 miles per second, which is 4,500 miles an hour. So if these two things slammed into each other at that kind of speed, they would explode, basically. They wouldn't be able to survive the collision. They wouldn't form into something that looks like a peanut or a ducky, a rubber ducky, right? So, but hydroplate theory, of course, can readily explain this. Once launched into space, the smaller debris gravitationally merged with rocks, and the velocities of these two asteroids being similar and similar directions would have allowed this to happen, would have allowed them to go into orbit around each other. And then, over some time, the smaller body might actually come in contact with the larger body and form into what you see here. And so this might have happened over maybe a few weeks to a year, but they gently merged together, allowing this to happen. Here's another picture of a comet named, another asteroid named Hartley 2. It's also peanut-shaped. There's a number of these. On November 4th, 2010, a space probe from NASA named Deep Impact passed within 435 miles of this. So to get a sense of the size of this, it's 6,600 feet wide, so just a little bit more than a mile. And there's another strange asteroid. This has been romantically named P/2013P5. Okay, maybe that's not that romantic, I don't know. But anyway, they nicknamed it Six Tails, because who's going to remember P2013P5, right? So for at least 5 months, it was observed to have what looked like a rotating lawn sprinkler. So the lead investigator, named David Jewett, viewed this asteroid from the Hubble Space Telescope, had this to say about Six Tails. He said, we were literally dumbfounded when we saw this 1,600-foot diameter asteroid. It was hard to believe we were looking at an asteroid, because nothing like this has ever been seen before. Astronomers are scratching their heads to find an adequate explanation for this out-of-world appearance. Why should we be surprised? The fountains of the Great Deep launch water, rocks, and dirt. Later, the gravity of each of these, drifting weightlessly in space, pulled in smaller rocks, water and ice, and dirt. Aerial braking of the water vapor accomplished this. So now we know that they're rock piles held together. And if there was some shifting inside of it, maybe an external impact or shift within an asteroid would open cracks that sometimes would expose some of its internal ice to the vacuum of space. And that would have caused what we see here, this ejection of vapor out. pretty amazing. Again, we have an answer for this. So recall earlier, we discussed the Chelyabinsk meteor that exploded over the city in Russia. This was in the southern Ural regions of Russia on February 15, 2013, and it caused some significant damage. So fear of this impact of an asteroid to the Earth has been the impetus for spending literally billions of dollars to find and detect similar asteroids that could have a real chance of doing this type of damage, with the thought here that there could be a way to deflect or alter their trajectories before they hit the Earth. So the result of this has been named NASA's Double Asteroid Redirection Test Mission, or DART for short. And NASA stated what we're trying to learn is how to deflect a threat that would come in. So the $330 million mission is taking aim on a stadium-sized asteroid named Dimorphos that is in orbit around a larger asteroid named Didymos that has the potential of causing similar damage to Earth as we saw in the Chelyabinsk meteor. So a small NASA space probe was launched on November 24, 2001, blasted off from California aboard a SpaceX Falcon 9 rocket on a one-of-a-kind mission to attempt to change the orbit of this asteroid, hoping to pioneer some way to divert asteroids in the future that could be on a collision course with Earth. So on December 26 of 2022, it actually struck this asteroid. So here's an animation of what the spacecraft would have seen as it approached Dimorphos. Dimorphos is seen as the smaller asteroid on the left, and Didymos is the larger asteroid on the right. So again, Dimorphos is orbiting Didymos. And it's the smaller one is the one that they think has a potential of actually hitting the Earth. So what you'll see here is the spacecraft is heading for a collision with Dimorphos, with the intent of impacting it to alter its orbit. And after you see the spacecraft collide with Dimorphos, in the animation, we'll switch to a view further out showing the current orbital path of Dimorphos around Didymos. And notice just before the impact, the spacecraft detaches or dispatches a camera to film what's actually happening in its orbit around Didymos. So let's watch this. So here we have the spacecraft, it's approaching, gets closer and closer. Yeah, this is an animation here. And then it strikes. Note how it strikes what appears to be a solid rock. Now we see the original orbit of Dimorphos, the DART spacecraft in its collision course here. Now it jettisons a camera here so it can film this as it's happening. And then this is the expected change in orbit around this asteroid. And now it's been deflected hopefully enough to where now it's not going to strike the Earth. So this is now hopefully a way to keep it from actually striking the Earth. Now here's a video that was shot by the dispatch camera along with a real-time view of the scientists who are witnessing this occur. So pay special attention to what they say as the aircraft approaches Dimorphos. As the spacecraft gets closer and closer, they realize that they're seeing individual boulders on the surface.
A continent on Earth.
Yeah. All right. 2 minutes out. Does not look like one single rock to me. Boy, we're getting close.
14,000 miles per hour, Lori.
14,000 miles per hour. And remember, 45 minutes ago, 55 minutes ago, we couldn't even resolve this object in space, and now you can see us zeroing in right on target.
And we're now dropping the clock, and we'll go by loss of signal to confirm impact.
Right. Yes. Imagine we'll get that loss of signal, and then we'll hear from Lena Adams again, letting us know that we've been successful.
I feel like that'll be a crystal clear signal.
I think so. I think we're starting to see more resolution. In fact, look at that. Didymos has even gone out of the view. We're now just seeing Dimorphos.
This is remarkable stuff.
Oh my goodness, look at that.
Looks like control system settling down, angular rates look really good. I think we're going to get the investigation team some good pictures.
Wow.
Again, this is a video that was taken by
No, come on, we can do better than
that camera that was.
Sorry, you see there's individual
Eject-
boulders there. You can see shadows of various rocks on the surface.
Now they're seeing rocks on the surface. Notice as it gets closer and closer, you start to see more
Look at
detail.
that. Unbelievable. Yeah. Looks to me like we're headed straight in.
Oh, what a surprise!
wow.
A bunch of little rocks on the surface.
Oh my goodness. 8, 7, 6, wow. 4, 3, 2, 1. Oh my gosh. Oh wow.
Awaiting visual confirmation.
All right. We got it?
Bunch of boulders on the surface. Okay, I heard the bell. I know we're out of time, so we'll pick up there next week. I'll probably show that video one more time, and then I want you to hear what happens after that. Very interesting.